start?
Breathe through.
All right, so we're going to go through both 9F.2 and 9F.3 at the same time. And then, we'll just get straight into both. So just like we did when we were doing D, remember we learned how to do a confidence interval, and then we learned how to calculate a sample size to guarantee a certain confidence interval. So we're going to do the same thing here with our proportions. So we've got for a 95% confidence interval, and we have a preliminary portion P hat is equal to P star for our purposes. That just basically means we don't know the actual proportion, so we're going to make an assumption about using the sample proportion. And so the formula we have here is n is 2 times 1.96. Again, the 1.96 is reflective of different levels of confidence, divided by the width squared, and then that's multiplied by our preliminary estimate of the proportion and the inverse of the proportion. So we'll continue with the above example. So we're talking about students that are playing Fortnite at Tennyson Woods College. And our question is, how many students need to be sampled to have a confidence interval with a width of 5%? Now we're going to do two calculations here. So we'll do the first calculation based off of the proportion we observed above, which was 0.55, 55 on 100. So we'll do the calculation with that value first. So we have n is equal to 2 times 1.96 divided by the width. So 5% as a percentage is going to be 0.05. 5% as a decimal, 0.05. That value is squared, and then we're multiplying it by 0.55 times the inverse, 0.45. And we'll evaluate that. Ratio. 2 times 1.96 divided by 0.05 squared times 0.55 times 0.45. We've got 1521. And again, like we were doing before, 1521.2, we round it up in order to guarantee that level of confidence. Okay, now in some circumstances, there will be some circumstances where we don't know the value of P. We don't have any idea what the value of P is. And in that circumstance, if you're not given a value of P, you assume P equals 0.5. And the reason you would do that is because if we use P equals 0.5, it's going to give us the largest possible value of n. Anything other than 0.5 will give us a smaller value of n. So 0.5 is like the worst possible scenario. Okay, so that's just keep that in mind for this exercise. There will be some questions about the worst case scenario. Okay, let's turn the page and we'll go through here testing a claim. So we'll have a read of it carefully. This is an old exam question. So, and I'll just say this about this unit. You can expect in this unit there's going to be lots of text, and what you've got to do is you've got to understand what it's asking you, you've got to read it carefully, and you've got to abstract out the necessary information. So what we have is in 2004 Australian federal election, 47.4% of voters in South Australia voted for the Liberal Party. A survey is conducted in 2006 to assess whether or not support for the Liberal Party in South Australia has changed since the 2004 federal election. A random sample of 80 South Australian voters are asked whether or not they would vote for the Liberal Party if a federal election was held today. 33 out of the 80 said they would vote for the Liberal Party if a federal election was held today. Okay, so we have from 2004, we have the population proportion, okay? It was 47.4%, and now it's 2006, according to this survey conducted in 2006, and we see that 33 out of 80. So part A says, using the sample data, calculate a 95% confidence interval for the proportion of all South Australians who would vote for the Liberal Party if the election was held today. So in our statistics mode, this is what we learnt yesterday. We'll go interval Z, first proportion. It's a confidence interval for proportions. And we have 33 out of 80 with 95% confidence. And so the confidence interval that we get is 0.305 to 0.520. How'd you get there? I'm going to have to come show you that a bit later, mate. We went through it yesterday, yeah. So then we have B. All right, so that's pretty straightforward. Just in your calculator, get out the 95% confidence interval. Would it be reasonable to claim this survey reveals that support for the Liberal Party in South Australia has fallen since the 2004 federal election? Explain your answer. So here we have, based on the sample, we're 95% confident that the true proportion lies in this interval. In 2004, the proportion was 0.474, or 47.4%. So based off of this, no, there is not enough evidence to conclude that support has fallen because the historical proportion still falls inside the confidence interval. So we need to articulate that. Would it be reasonable to assume? No, the confidence interval does not support this claim. And then we can say the 2004 proportion still lies in the confidence interval. All right. How large of a sample is required to produce data that will result in an approximate 95% confidence interval with width no greater than 0.02? So this is our N formula. The width is 0.02 squared, and we'll use the probability that we have here. It's at 33 on 80, and so what? 47 on 80. Evaluate that. All right, we get 9,309.8, which is 9,310 people. Excellent. So there you go, guys. You know everything you need to know. So good luck in the exam.